Hey everybody, I'm Darren. SOLIDWORKS Costing is a great tool that automates an otherwise time-consuming, tedious, and incredibly error-prone task of cost estimation. You can cost parts using a SOLIDWORKS Professional license, or you can cost assemblies using a SOLIDWORKS Premium license. And it works for sheet metal parts, machine part types from either a mill or a lathe, 3D printed parts or plastic injection molded parts, and even weldments. Today I'm going to show you how to set up your costing templates by either editing a sample template or creating one from scratch. Let me show you. There are two different approaches that we would use to set up the SOLIDWORKS costing templates. Both of them start, however, by opening the costing template editor. So you can do that in Windows 10 by just hitting the search bar and just typing the word costing. You'll see one that's specific to your version. When you open the costing template editor, the two methods would be to either create a brand new template from scratch or to open an existing template and edit that. I would recommend opening an existing template to see what's in it. Could very well easily be more of a process of elimination instead of creating something from scratch. Now, the default templates are located in your install directory, which is typically the C drive, but then we go to Program Data. Now down to the SOLIDWORKS folder, and then your version specific. We'll do 2017 for mine. It is language specific, and then we are, of course, English. So there you're going to see your costing templates folder. Pick either machining, multi-body, or sheet metal, and then choose the English standard if you'd like English or metric. So we're going to open up the English standard. So the first step here is to deal with the basics. Now generally here it's set to the English standard since that's the template that we selected. If we'd like the ability to edit this now, we're going to go ahead and save it to a specific name. So I'm just going to do a save as, and then we'll just throw this one on the desktop or back in the same location would be the most likely best place for customer use. I'm just going to call mine Darren's Machining Template 2017. Set your dollar values and then move on to the next step, which is machining. So this is the material selection area. Different types of disciplines or the type of geometry would determine whether it's a plastic, a casting, or a machine part with prismatic features and holes and possibly fillets and chamfers. Now this could be set up the way that you would like it specifically. You just have to take away some of the ones you might not need, and if that happens to be the case, it's really just a simple matter of grabbing the row and hitting the delete button, and then that will remove that particular row. To add things, we simply go down to the bottom, and on the last row you would select the class. This is tied specifically to your SOLIDWORKS materials templates. So in this case, we would select the material that you would like. From that list, you'll go ahead and get another material list. Will be specific to the top level list of steel. We'll just choose ANSI 1020. And then from there, it's the type of geometry. Now this will have a triple pronged effect. If you select block, it will simply gray out the thickness and then just simply ask for a dollars per pound. So if we say $10 per pound, hit enter, and then that will open up the next line. Now if we do the similar type of feature, I recommend changing this up to a different material class if you are creating this from scratch, and it will show that. But if you select it from the list here and grab a different type of material, or even the same material, 1020 steel, and then change this one from block to plate. Now we're talking specific purchased thicknesses. So if we do a 1/2 inch of thickness, and then a very similar, but maybe in its purchased configuration, it would be a little bit more expensive. We can type in a different price. Again, I'm going to go through one more here, which will be the same thing. We'll do steel, do a 1020, and then we'll choose, in this case, for turned parts, a cylindrical body. In this case, the same type of thing. It gets rid of the thickness value and then determines dollars per pound. Let's type that in properly. Now, if we're creating this from scratch or want to do mass edits here, we can take the table set that we have right now and actually export this to an Excel spreadsheet. By doing that, it's going to give you a file that you can edit in a more powerful table editing tool. It would allow you to copy and paste rows, use formulas to create differences, maybe in the cost versus the thickness value, or have some sort of formula that correlates those. But it also allows for a bit more of mass editing in a tool that's built specifically for that type of feature. If we're creating it from scratch, that's also a very good way to go, is to create a few baseline features and then go ahead and export and do mass editing. Here we're going to stick with the template. So for the machining template and other types of templates, we would specifically fill this one out for those other disciplines, and it will then take those types of properties for different methods and use those for the appropriate types of parts. Typically though, we would go from the one specific discipline we're looking for, which is machining, down to setting up the machines themselves. Now again, these machines have different purposes, whether it's a more of a machine tool that could be milled, turned, and or drilled in combinations of those. If you're just simply cutting, this is going to be more of a flat sheet metal type of a feature here, so water jets, plasmas, or lasers. End cutting is really just a cut-off machine, so if you have long stock, this is going to be one cut that creates that feature. Might be necessary per part in some circumstances when you're cutting off of billet that is received in bar or long form. And then for plastic injection molding and die casting, there are different methods as well. Now these specifically talk more about the type of geometry when we're talking machining, but then they all get into basics of dollars for the machine, the labor cost, what their capabilities are, and then some specific hard values for things like setup times and load times. So to set these up, it's exactly the same thing. We go to the bottom, we simply type in a value here, and I'm going to call this auto mill just for fun. That's going to open up our check marks, which is going to give me, in this case, milling and drilling. I'll select. That way, geometry specific, it would select this machine possibly. For this one, I'm also going to use a machine cost. We're going to call this one just maybe $5 an hour. And that's an interesting thing there, just because if it's an auto machine, it wouldn't have necessarily a labor cost of a person there. So maybe this is actually going to be 0. Now, max RPMs, we'll stick with the 15,000 capabilities. Load and unload time, made it an automated machine, so maybe this is a 1-minute unload time. And setup time could be just down to 5 minutes. And this is all fictitious. But these values are set based on your known costs, and then they're applied, again, through the costing template, either to each specific part if you choose, applied over the lot size or the total quantity. And that'll amortize it, or that will just make it a one-time deal. Or in this case, I'm going to call that applied per part because it might be quicker, but maybe it's an individual setup that happens each time that part comes through because of the automation. Again, this is very specific to your own processes. So once these are all filled out, we would move down to the types of operations, and this is where all the speeds and feeds come into play. So the type of materials, and in fact anything selectable from this list, it's all correlated from everything else created above. So the class is the types of materials that we use for machining. The materials themselves are also parts of those lists, and then the machines that we have to select from are the ones that we specifically set up in this machining list. So as we go down the list here and try to add another one, you'll see that these pull-down lists are very much shorter than the originals because we're pulling from now the truncated list that was added above. So if I select specifically an aluminum alloy and hit from the list again, there was only one that we even set up. That one did have multiple capabilities, so we could select from what we had determined before as the capabilities for that material. And then from there we can select from, again, a truncated list of only the materials that we keep in stock according to the lists we created previously. And then from there, we're going to go ahead and have the cut time that we might have. So seconds per inch on a machine, when we talk about water jet or laser, those are the types of values that we get that will be determined through the costing templates by actual profiles, internal or external features of the geometry, especially with sheet metal. But these are the ways that it then knows how to apply particular methods to that particular type of material. Now there was a little message that popped up right there, and that basically said that I'd already determined what that material was up above, and it didn't want me to duplicate that. So that's an actual safety feature that makes that happen. But as we go, we need to then get into the specifics of the mill. Now this is going to be, once again, filling out individual lists. That list is going to be relative to the material lists above, and then the types of machines that we have to select from. Each of those, then you determine a tool type that's going to be in your crib. So this is essentially like setting up machining processes where, based on physical geometry, it will either match a drill type to a hole, or if it finds out that it's an odd size hole, it will have to do a rough and then finished pass, again, based on the tools that you do have available in your machining centers. So that's going to give us the most accurate representation of the costing values. Once again, all the way to the bottom, you would be selecting from lists you've already created, material lists that are specific to that previous list. And just to show that a little bit more, I'm going to hit coppers instead. You'll see that copper actually has 2 in it based on its list. The machines available will be set based on the machine set above. And then again, you're just selecting now from a given list of types of tools. So if you have a ball nose that you use for a rough or semi-rough, you determine the sizes, the inches per revolution. So these are going to be the specifics to that table over there. It's all about material removal rate. So unlike a machining product that's actually doing tool paths and passes, this is just trying to figure out how much material it can take off of the part at any given time. So it becomes a process of elimination with the costing evaluation, where it's determined based on the stock material we're beginning with and the finished part that we're ending with, and the fewest amount of operations that we can actually remove that material. So the formulas are listed specifically for each type of operation. If you're wondering how each of these types of values actually injects into this formula. And again, that's very specific to a mill type or a drill type, which is based on the size of a tool plunging into a part. Turning is again based on other things like RPMs. And again, the material removal rate does take those into account. And then the end cuts. So cutting off of steel or aluminum stock, and basically 1 cut feet per minute. There are also inputs at the bottom here for library features and custom features. Now it's best to get things set up at least a little bit and see how they go before we start to get into the minutia. But when you have operations that are regular, so features that maybe you use in the design library that then are going to correlate to the exact same feature each time it's machined, if you know how much that feature actually costs, you can eliminate some of the performance calculation hits just by simply having that library feature as a finished determined flat cost. So that's something that's based on maybe features that you reuse in the SOLIDWORKS design space. So if that's not a consideration, that's something we can skip at this point. Now custom features, however, are more like pre or post process operations. So if you select a particular type of operation here, it can be added either automatically based on a rule or just manually based on the type of geometry that you're dealing with. So maybe a post process is going to be the anodizing of an aluminum part. That would be something that would be tacked on to every instance of that aluminum part based on the criteria, whether it's divided over the lot size or whether it is an individual per part count. So these would be things that you specifically do to treat that part, whether it's an etching process again, or a painting, acid dip, anodizing, or whatever that happens to be. Now this is the operation we would use to start from a very mature and good layout type of a costing template. If there's more information here than is necessary and you would prefer to start from a blank slate, then you simply go up to the New button. Now here it will ask you specifically for the type. So if you're talking structural steel and sheet metal parts, multi-body might come into play, sheet metal specific individual parts, or the machining, molded, or 3D parts. That's the one we're filling out previously. So if we open up a clear template, and I'm going to not save what I've done here, what we'll then be presented with is essentially a list of all complete blank slate, including no operations to even select because we haven't defined the types of materials up above yet. Here you're free to go ahead and select the default standard, which is the one we get from our SOLIDWORKS installation. We switch down to machining, and again a blank slate. We are picking from a clean list. So this is based on your material templates inside of SOLIDWORKS. We choose from the list, add the material that you need, say alloy steel or 1020, and then the stock type. Now once again, here if we select block, it's going to blank out the thickness and give us a hard cost per pound. If we do the same type of thing here, we can go ahead and select it and select it here, grab it from the pull down list, and then again walk through that same type of material. So maybe we have a couple of options based on the materials that we have. So again, block versus plate. Plate would have a specific thickness, and plate might be a thickness that you have maybe 10 different thicknesses for. Now this is a circumstance where if you're looking at, say, starting a brand new template but still would like to use Excel to help with the speed of this. I'd recommend giving yourself options in the proper syntax and then exporting to the Excel spreadsheet. So if you have multiple materials, put one of each in. So say get an aluminum alloy, maybe take one aluminum or multiples to get at least one of each material that you might use on the list. And that's more for setting up the copy and paste properties inside of Excel. Here I'm going to go ahead and choose cylinder type just to get a different one here, and then see that that's not available. And we'll go ahead and put a value in for that price. But if you say went ahead and did something like another aluminum alloy, and maybe changed it up a little bit if you have some T6 available, and maybe this one's going to show up as a plate. And this is really, again, just to be a nice prompter to format your Excel templates to. Once we have multiple materials like this, we can simply say export. We're just going to save this as a temporary file for now. So on the desktop, we'll just go ahead and paste the document. And then what we'll do is go ahead and save that file and open up Excel immediately. Now from here, we're basically doing a mass copy and paste. So if you want to give yourself some space and grab a couple of rows, you can use the Excel functionality to go ahead and do things like automatic increment. We can use copy and paste to take what we have here and maybe copy it down an entire row, or maybe simply copy from the list and paste it into a different cell. But this gives us the capabilities to take multiples and at least be able to maximize our input. So by grabbing multiple cells and pasting those in place, we've got a little bit of that syntax. And maybe if I went ahead and did some plate and some thickness, this would be one where I'd want to make sure that those values go together, because of course it's blank when it's cylinder and block, but it has a thickness for plate. So here I might put in one for a steel, and this time I'm going to go ahead and add a little thickness to that. Now a great part about Excel is its flexibility. This would be something where I might want to go ahead and take, let's say, these materials out, and maybe just get those out of my way so I could reorganize some things here. And then from that point, using Excel functionality, you'd be able to do cuts and pastes to be able to put things in proper rows. And again, if I had multiples here, I might grab two cells. When you grab the corner of that in Excel, it actually bumps those up, the delta between the two cells that we selected. In this case, it might be the exact same information here, so holding the control key down and dragging that corner allows me to copy the exact same values. And maybe if these are going to go up $1 in value, I'd type a 12 and a 13, grab both of those cells, and with no keyboard selection, pull down in the corner, and that will then do some math and automatically increment those. So these are some interesting ways to get additional cells in a much more rapid way if you want to maximize the use of a tool like Microsoft Excel. Now once I've got what I need, I'm going to take this and save it, and then we can close it. And then back over into our template editor, if we do an import, we're going to grab the one that we just saved on the desktop. Once we do that, it'll import all of the cells and will basically update our template for us, and it will tell us what took place. Now update would be that if we exported this to Excel and then modified some of the rows that we already had. In this case, we went ahead and just put new rows in addition to what was already there, and it's going to go ahead and just import those values. Now it tells you what's been imported. It would tell you in green cells if maybe we tweaked a value outside in Excel, and then it refreshed back here in the template editor. At this point, if you want to make this more internal, what I like to do is just tap on, say, the material, for example, and what that will do is then correlate it for sure back to the original material list and just basically treat this cell as if it was created here in the template editor as opposed to have being imported. If you do another round robin and export again and then re-import, any new cells added will show up in that blue color once again. All we then need to do is repeat the process. Go through and set up the machines from scratch. These are arbitrary names based on what this means to you. The capabilities are specific to what they can do. And then the hard costs for machine cost, labor, the max RPMs, unload and load time, and any setup or operation time taken. So once each of those values has been populated, we'll go ahead and get another row available to us. 5 minutes of unload time, 5 minutes. Now one other machine I'd like to go ahead and add is a cut machine, because that's going to be necessary for the cut plate type of stock, which we have quite a bit of up on our materials. So we'll just go ahead and add a machine name, once again arbitrarily, and then some other values that we'll add for dollars per hour, and labor costs, time to set up and operation time, and application of the material. So if you have to cut it off each per part, that would be more appropriate. When we go down to the operations here for cutting, this is where we're going to go ahead and select from now our truncated lists. So if we grab an aluminum, for example, we only have one that we placed on our list above. And then we have a cutting machine here in order to go ahead and create that feature. So thickness list here, we only had one aluminum at one thickness. And we're going to do a length, which is seconds per inch. Let's go ahead and say maybe 60 seconds per inch. Now the next class I'm going to do on this one, I'm going to choose from the steel, because from this list, although we had one material, and again only one cutter machine to select from, we do have multiple thicknesses available based on how we used our spreadsheet. So this will be the same type of thing, maybe 60 seconds per inch, and so on and so forth. Now milling, we're going to have to go ahead and set this up from scratch as well. So this is where the ability to go ahead and use an existing tool set for this, or an existing template, might be the more appropriate way to do this. You notice here when we go into our materials, we have our truncated lists once again based on what we've set up prior to this. The types of tools are specific to what you have available, so this list will be standard. And then filling in the specifics based on the material removal rate criteria shown in the key. Repeat the process for drilling and turning if necessary. And then set up any library features that you might have set up in your SOLIDWORKS library, like a slot or a pocket or a machined attachment point of some sort. And then custom operations will be set up based on post-processing. So these are arbitrary names. Based on criteria, whether it's the weight, the face, or the surface area of your part, or volume or additional material, cost of that operation, and whether that has to be set up each time. In this case, if you set it to be include always, it will be a default. If not, this would be a manual application, either per part or what the other setup distribution would signify. So make it a default by saying yes, and this will happen on every part operation and be applied be applied automatically. So once that's all done, you're going to want to go ahead and save your template. And from there, we go ahead and just simply tell SOLIDWORKS where to go ahead and look for those templates. Now, if you placed it back in the standard templates folder where we selected the original template to begin editing, then SOLIDWORKS will already be looking in that location. To go ahead and make SOLIDWORKS look at that location automatically, we go to Tools and Options at the top of your SOLIDWORKS interface, down to File Locations, and then we select from the category Costing Templates. From there, we simply add the folder that contains your costing templates, and as you can see here, there can be multiples. And from there, it will either automatically apply it if it is your default template, or it will go ahead and allow you to select from the list to apply the template on a part-by-part specific basis. If you're then running any costing operations, you'll simply have the part in your SOLIDWORKS interface. SOLIDWORKS Premium allows for costing from the assembly level, and it would individually cost every specific part based on its default material types. When we go ahead and hit the Evaluate button, we launch SOLIDWORKS Costing. And in this case, it's going to give me a list of my assembly costing templates. And as a demonstration file, it also indicates parts that have already had costs defined through running the templates or through hard-coded cost values based on purchased values. There are also parts in mine that need to be costed yet. Now, to run costing, you would simply open up the part in its own window. Select the costing from the right-hand File Explorer. And then from there you would select your template. By selecting your template, it will simply apply the costs based on your specific materials available. The geometry is generally detected based on the plate material or the block material that would be available. You can also select that manually to apply a different cost. So if our part is currently $14.78, we'll set that as our baseline. If I was to go ahead and select a different type of material, maybe switch this up to an aluminum based on what I might want to make it out of, it will then go ahead and update my costing based on the aluminum materials available and their particular values. These lists right here, again, are also based on what is in the costing template. So by selecting from coppers or steels, I'm only going to get, in this case, my brass plate. Or if I select from my steels, I'm only going to get the shortened list that we have in our default template, which in this case is plain carbon and AISI 304. Every time a change is made manually, you'll see the correlation of the new costing data relative to the old. Green would indicate that the new data is now giving you a less expensive part. Red, in this case, shows you that we are now 126% worse off based on the material that I've selected. Selecting from a different stock could also have an effect. And in some cases, we don't want to update you every single time you select minutia, so clicking to update would then manually update our costing value. So that basically covers the way the information is plugged into the costing templates and how to run those costing templates on your existing parts. I am Darren at GoEngineer. Thanks for watching.